Hey guys, how are you? And I'm back with another video here. Jalaj Aurora here from Be a Gem at GCSE Chem. And I'm recording the second section of the AQA GCSE Chemistry textbook. I'm using the revision guide. This revision guide, not using the student book, but that's just a more bigger version of this. But I find this one better, in my opinion. Today I'll be teaching you 1.2 or C1.2, which is chemical equations. Another very straightforward topic. It should be, hopefully, very important topic as well. So chemical equations. So if you haven't checked my video on atoms, which is C1.1, make sure to check that one out. I just made that one yesterday, and I'm aiming to make videos every day if I can on every single topic, so that it helps you when you want to revise stuff, But let's start. So chemical equations show the reactants, which are substances you start with, and then they also show the products, which are new substances made in a reaction or a chemical reaction. So or in any reaction, basically, that you have reactants, which are on the left-hand side, and the products, which are on the right-hand side, and between them you have an arrow, basically separating them out. And word equations give the names of reactants and products only. So that's, word equations, they're useful. Like, they tell you what elements are reacting together to form what compounds and stuff like that, or, what things are reacting. It doesn't have to be elements reacting. Whatever's reacting and whatever's forming, it just tells you that. But we're going to later see, actually balanced symbol equations, which are much more useful in chemistry calculations to find things like how many moles of some substance is reacting with how many moles of another substance to form how many moles, or the mass of something. You could do so many calculations with balanced symbol equations, so they're much more useful than word equations. But word equations, they have their uses as well. So what is the word equation for the reaction between hydrogen and oxygen to produce water? This is a question in the book that I'm using. And by the way, if you're using the student book following on, it's pages 6 to 7 that I'm doing, but not all of 7. Pages 6 to 7 in the student book. So write an equation for the reaction between hydrogen and oxygen to form water. Well, that's quite easy. You're just going to write hydrogen plus oxygen, arrow, water. That's all you have to do for a word equation. It's as simple as that. Just literally write everything out. Like, no balancing required of atoms or stuff like that, because you're not using symbols. But it's a very easy question, that one. And normally they could ask you word equations in exams, but it's most likely going to be symbol equations, because they're more useful. So in chemical reactions, atoms get rearranged. Now symbol equations show that the numbers numbers and types of atoms in the reactants and the products. That's what I was saying. They show the number and the type of atoms in the reactants and products. So they're very, very useful. Atoms are never created or destroyed in a chemical reaction. So the number and type of atoms remains the same before and after the reaction. So, before reaction and after the reaction, the number of atoms on the left-hand side, number of atoms on the right-hand side are always the same. It's like, atoms are never created or destroyed. It's just like energy. Energy is never created or destroyed. It's only transferred between one form to another, which you would have learned in, probably learned in GCSE physics. But in GCSE chemistry, we talk about atoms. Now, when writing symbol equations, you should always balance the equation. A balanced symbol equation has the same number of each type of atom on both sides of the equation. On both sides of the equation. Use multipliers, which are basically numbers placed in front of the formula to ensure symbol equations balance. Now, we're going to get onto a very, very important point in a minute. This is very, very, really important to get in your head, because otherwise you're going to lose marks. But the next thing is you can include state symbols in balanced symbol equations, and these are S for solid. You use S, L, G, and AQ for solid, liquid, gas, and aqueous, respectively. And you basically put, for example, for solids, you just put S in curved brackets. For liquids, you do L, you put L in curved brackets. For gases, you put G in curved brackets. And then for aqueous, which means dissolved in water, for aqueous solutions, you put AQ in curved brackets. So these state symbols are actually really, really useful. We're going to see, in later chapters how we can form ionic equations using these state symbols. They're actually really, really crucial actually to know what state a substance, what state something is, and it really helps us to form other equations like ionic equations, for example. But then it says balance the equation H2 plus Br2 gives you HBr. Now before I already did this question actually before before recording the video, so I'll just show you what I've done. So as you can see here, I've done, H2 plus Br2 gives you 2 HBr. But when you're writing this, what you're going to write first is H2, you're going to write plus Br2 gives you HBr. You're going to write that first. Because you just need to know which elements are diatomic elements, All group 7 elements are diatomic. Hydrogen's diatomic, oxygen, nitrogen, I think that's about it. Hydrogen, oxygen, nitrogen. I believe that's about it. There may be more, but yeah, they're basically the main ones. Hydrogen, oxygen, nitrogen, and all of group 7 are diatomic molecules. So you always write them as H2, Br2, O2. They never exist on their own. They just don't do that. They just, they covalently bond with themselves to form a hydrogen molecule, an oxygen molecule, a fluorine molecule, a chlorine molecule. What I was saying, basically. It goes on and on and on for these specific elements. But basically, yeah, so you write H2 plus Br2 gives you HBr first. Then what you do, this is when I was doing my GCSEs, I always used to write all the elements that are involved. So hydrogen is involved in the reactants, bromine is involved in the reactants. So hydrogen is involved in the products, bromine's involved in the products as well, obviously, because an atom that is in the reactants will also be an element in the reactants will be an element in the products, basically. Then I basically count, then what I do is I count the number of atoms on each side of the equation for a specific element. For example, hydrogen, when I write the equation, it's there's 2 atoms of hydrogen on the left hand side on the reactants, but then only 1 on the right hand side. And same for bromine, there's 2 on the left hand side and 1 on the right hand side. So then when I know that the hydrogen and the bromine don't balance, what I basically do is I put a 2 in front of the HBr, because first it was H2 plus Br2 gives you HBr, so I put a 2 in front of that, and it just all balances. You have 2 hydrogen atoms on the left, 2 on the right, 2 bromines on the left, and then 2 on the right. So they all balance. And one important thing when balancing equations is you must never change the formula of a reactant or product when balancing a symbol equation. Now what does that mean? That means that what you can't do is you can't basically use subscripts. You can't use little numbers. You've got to use kind of big numbers. You can only balance equations using big numbers, because if you were to use small numbers, which are subscripts, you'd be changing the chemical formula. For example, water, H2O, is completely different from H2O2, which is hydrogen peroxide. They're literally not the same compound. So you can't just change a chemical formula when balancing symbol equations. That's a very, very important part, and it's actually even here as well. In the study tip, I don't know if you can see it properly. Yep, there. So, but basically, you cannot use small numbers to balance equations. That's the main thing. And yeah, you should. So it says on this, on the up thing, it says you should be able to balance symbol equations, including state symbols. You must include state symbols if they ask in exams. Higher tier papers, you should also be able to write balanced half equations and ionic equations, which I will come to as we go on with this kind of teaching in the next chapters. But now we go on to law of conservation of mass. So the law of conservation of mass states that no atoms are lost or made during a chemical reaction. So the mass of the products is equal to the mass of the reactants. So yeah, mass of the products is equal to the mass of the reactants. So in some reactions, this law seems to be broken. So this isn't like a hard fast law. Like it's a law, like law of conservation of mass, but it's not always true. Like there are exceptions. Like for example, in some reactions, the law may be broken because of sorry, 1 minute about the phone there, if you can hear it, sorry about that. But in some reactions, the law seems to be broken because the mass appears to change. Now this is usually when gases are reactants or products. For example, if a product is a gas, it may escape into the air. Sometimes substances increase in mass when heated. The extra mass is because oxygen gas from the air is a reactant. So basically what they're saying is, this law that we say, law of conservation of mass, the law that states that, the mass of the reactants and the mass of the products are equal. That's not always the case. For example, if you have a reaction that produces carbon dioxide, it's very likely that that carbon dioxide will escape into the atmosphere or into the air, and basically you'd have a loss in mass. Or when you could even have an increase in mass as well. But basically, it's not a very, you don't need to know much about this. You just need to know that there is something known as law of conservation of mass, and you also need to know that it's not a rule that is like that always works. Like there are exceptions, and you need to be able to give like an example of an exception. For example, if carbon dioxide gas is produced, this would cause a decrease in mass. So things like that, very important. Now what law states that the mass of the products formed in a reaction is equal to the mass of the reactants? Well, that is, sorry if you can hear the phone, but mass of the products equal to the mass of the reactants. So that is 1 minute. Yeah, mass of products equals mass of the reactants. So that is obviously the law of conservation of mass. So keywords here are reactants, products, word equation, balance symbol equation, state symbols, aqueous solution, and law of conservation of mass. Now before we finish, we just want to go over the key points. No new atoms are ever created or destroyed in a chemical reaction. The total mass of the reactants equals the total mass of the products. That's the first thing. Total mass of reactants equals total mass of products. No new atoms are created or destroyed. Remember, just like energy is never created or destroyed. There's the same number of each type of atom on both sides, on each side of a balance symbol equation, and you can include state symbols to give extra information in the balance symbol equations. So the symbols are, S for solid, L for liquid, G for gases, and AQ for aqueous solutions. These must all be in lowercase, and you must put curved brackets around them. And I hope this was useful. So that's the end of this section. Tomorrow I'll be making a video on separating mixtures, which is 1.3. So including things like filtration, crystallization, distillation. So very, very important stuff. But I think I'll end the video here. Hope it was useful, and if it was, if you haven't subscribed already, subscribe, share the video, share, like, and subscribe, and I'll see you in the next video, guys. Thank you very much.